right, everybody. Thank you for joining this session here today. So I'm Chris Jones, one of our professors of information systems here in the UC Linder College of Business. And I have the pleasure of introducing Kunal Sonalkar, sorry if I said that wrong, who is a data science from Nordstrom. So Kunal is a data science from Nordstrom, a fashion retail and e-commerce company. In his role, he focuses on improving the online shopping experience by enhancing search retrieval systems and developing personalized product recommendations for digital customers. He holds a master's degree in computer science and engineering from the University of Florida. So let's give him a warm round of welcome here.
Hello, good morning everyone. Am I audible at the back? Can everyone hear me okay? Okay, so let's get right to it. This session is mostly going to be about recommendation systems, somewhat of search retrieval as well. And I'll try to make it as interactive as we can, and if you have any questions, just feel free to interrupt right then and there. How many of you have been actively working in the recommendation space, or will be working, or just interested, I guess? Okay, cool. So this library which we are going to talk about, Transformers for Rec, is essentially an open source library by NVIDIA, and we'll get into the nitty-gritty. Okay, so just a little bit about me. I'm working at Nordstrom as a data scientist, mostly work on search, recommendations, and very recently merchandising. So if you go on our website and if you search for a particular clothes or shoes or accessories, we try to show you as relevant results as possible. I got my master's from University of Florida, and I love reading, long distance runs, and playing badminton. I have attached my LinkedIn profile. If anyone wants to connect with me, feel free to reach out. Okay. Now, speaking of recommendations, why do we need recommendations in the first place? So if you look over here, there are a lot of touch points where customers can be reached out to through the recommendations. So one could be, let's say the customer is searching for polo shirts, and we show them these polo shirts. We know that we want to show some alternative options as well. So one of them could be black t-shirt or gray t-shirt, or a polo collared t-shirt, so on and so forth. Then complementing to that, they have shorts as well, where we can show them these are the alternative products which you might or might not like. Then apart from that, we also show them you might also like, or people who bought these sorts of polo shirts also have bought these sorts of items or apparels, so on and so forth. And then let's say if the customer goes through add to bags or checks out till the last page, then we can also show them a little something extra, which is, hey, are you forgetting something, or would you also want to buy this, or would you also be interested in buying socks, so on and so forth. So there are a lot of placements and strategies through which you can sort of cross-sell different products to the customers. And I think most of us have been sort of exposed to this if you shop on Amazon, or if you shop on eBay, or any e-commerce website would try to sort of cross-sell you. So that's what even we are trying to do, and we are trying to make it as relevant as possible, as personalized as possible. So yeah, this is the effort for that. So before we get into the current library which I'm going to talk about, let's first talk a little more on the traditional machine learning techniques which have been fairly adopted now. So one is the content-based filtering. So content-based filtering it only works on how similar your content is or how similar your products are. It has nothing to do with how users are interacting with it or how similar two different users are. So if you look on the right hand side, let's on the y-axis you have certain apps which have been deployed on Google Store, and they fall into few of those categories. So the first app which you see is part of education, and Science are us. The second app is just casual or maybe a time waster app. The third app is associated with health and healthcare. And then the fourth app is more on the education side, and again science, and then healthcare. So essentially, we are going to look at how similar these apps are, and we are not going to compare like how different users are interacting with it. So if I have interacted with, let's say, an educational app, I'm going to get recommendations of similar educational apps. So my behavior is not going to be compared with different users as such. So this can be, and this requires like substantial amount of user data to function effectively, because since I am the only user and I'll be shown recommendations based on my historical interests and past purchases, it requires like significant amount of user data. And sometimes this approach sort of struggles with the cold start problem. So if a user visits my website and I don't have any information on that user and he or she is visiting for the first time, I don't have any historical data. So in that case, this approach is going to struggle. So eventually, like once the user comes, they interact, they give some sort of signal, then we are able to sort of modify our recommendations based on their preferences. Another part where this approach would struggle, does pretty good, is getting diverse recommendations. So this is not more like a popularity-based contest. This is more to do with how your product descriptions are, or like in which category your particular product is falling into. So even if a particular product has not been interacted with as such, or does not have, let's say, product reviews or feedback as such, there is a good chance that product will be recommended in this approach, even though we don't have, even though that product is not very popular to begin with. So this approach works very well in terms of enhancing your discovery or giving boost to the new products, as long as you have a significant user history and past user data, and then you can develop recommendations based on that. The second traditional approach, which has been sort of fairly adopted, is collaborative filtering. Collaborative filtering, I guess, it became very popular with the Netflix recommendation challenge which came out, and they had open sourced like a good amount of data, and they wanted to sort of develop recommendation engine, and it was like a pretty big competition, and collaborative filtering was sort of the one which sort of outdid most of the benchmarks over there. And in this collaborative filtering, what we do is we sort of create a matrix, which is the user item matrix. So let's take an example of like there are a few users over here who like a certain set of movies. And what we are going to do is, or like what this approach does is, it sort of creates an embedding and it breaks it into a matrix. And that matrix in itself is sort of a decomposition of how user and items have interacted with each other. So essentially, you will, at the end of the process, you are going to get a user embedding as well as you are going to get an item embedding. The good part about these embeddings are they are in the same space, or like same vector space, so to say. Now, what will happen is, in this case, we know like what users are sort of similar. So if I know that a person X also likes a certain movie, then person Y also likes certain movies, we can say that person X is very similar to person Y. And let's say if person Y interacts with something new, that recommendation can be shown to person X also, because we know that person X and person Y have been like very similar. So, okay. In terms of understanding the user profile, this approach works very well because you are not restricted by the cold start problem which you had in the content filtering approach. So even if a particular person does not have like vast amount of history associated with him or her, this technique can still fairly survive and give good recommendations if we are able to establish some sort of similarity with the users. So in the first approach, we were just concerned about the product-based similarity, and in the second approach, we are sort of doing product as well as the user-based similarity. Other than that, one more positive point of this approach is the transparency. It specially offers like very clear explanations on like why your recommendation engine is working a certain way. So if you are sort of comparing two users on the scale of how similar they are, this approach is fairly good in explaining like what parameters it's getting and or like what kind of conclusions it's drawing to get that user similarity. Okay. Apart from that, I think one aspect where this approach might lack is the diversity or like how it recommends the newer products which have not been interacted with. So since this works mostly on a matrix which is like user item interaction, new items don't have that much interaction. Like they have not been clicked on or they have not been added to bag or they don't have their reviews on the website. So if certain set of products have like absolutely no user interaction, this approach might struggle in that sense because we won't be able to recommend or we won't be able to create an embedding or a more contextual sort of history associated with that particular product. So I think currently in most of the companies or like in most of the systems, these two approaches work hand in hand, collaborative filtering as well as content filtering. Okay, now a motivation for sequential recommendations. So most of the approaches or like the approaches which we just saw, the recommendations are sort of static and they are batched. So when I say static and batched is like in our scenario, like the recommendation engine runs every night and it updates the recommendations based on that day's how the customer has interacted. Now, does it always have to be like that? Like, can we do this recommendation real time? Or like, can we move away from this problem of running a batch every night, then refreshing the data and then rendering your recommendations the next day? Do we have any option of adding some temporal effect to the user recommendation? So for example, 1 week ago, the person was searching for laptops, then today the person is searching for some clothes or interacted with some clothes, but then also simultaneously has been interacting with desks or like office furniture, so on and so forth. So what exactly is the person looking for? Like, can we get some sort of context just looking at their current interactions or clicks or how they have been adding to bag the products? So that is like the main motivation for your sequential recommendations and to get a better personalization on how the user has been interacting. Okay, before we go forward, how many of you are familiar with the transformers architecture? Okay, few. How many of you know like how they are trained on like the language models? Okay, few. Okay, so I'll try to sort of give a brief introduction on like how transformers get trained as well. So essentially, one good part about transformers is like they are very good at understanding semantics in a particular language. So for example, let's take these two sentences, right? The animal did not cross the road because it was too tired, and the animal did not cross the road because it was too crowded. So in both of these sentences, the word it, in one sentence, it is referring to the animal, and then in the other sentence, it is referring to the road. And if you look at like how these transformers or like the transformer architecture works, is it is able to establish like where that animal is associated with it and where the road is associated with it. So essentially, if you feed this particular sentence in a transformer model, it will be able to correlate animal with it in the first sentence, and in the second sentence, it will be able to correlate the road with the word it in the second sentence. In another example, if you notice, the sentence is the lamp emitted dim light which illuminated the room. So if you notice, the light word is associated with lamp, emitted, and illuminated, right? So these are the three words which are more contextually aligned with the word light. But in the second sentence, he found the suitcase was surprisingly light as he lifted it. So in the second sentence, the light word is associated more on the suitcase side and lifted side, right? So the same word has different context or different semantical meaning or the way you use it. And Transformers has been doing a great job at getting or like decoding this context and decoding the semantics when you train it or like when you give this entire or when you create your language model as such. So if we are able to decode this particular semantic or context of different words, like can we do the same thing for products? So now just to give a brief history of transformers, the way they work is it works on a next item prediction task. So you feed a particular sentence and you ask the transformer model that, hey, what is going to be the next word or what is going to be the next bunch of words once I finish this sentence. So many of you, I mean, like, I'm guessing almost everyone has used ChatGPT at this point. So the way you work or the way you interact with this ChatGPT is you give the sentence and then it is sort of predicting the next words which are the most relevant given that your context or given the sentence you have provided. So the same thing we are trying to replicate for the product recommendations as well. So let's take one more example on how we are modeling the same thing for products. So the same next item or word prediction, can it work for the next product prediction? So in this case, now this sequence of items which you see over here, right? So there is this black shoes or like black sneaker shoes which has been interacted with. Now this interaction part, if you notice, this is more associated with the outdoor recommendations because the customer is interacting with more outdoor clothes. So the black sneakers and then the rain jacket and then the closed shorts and then the outdoor shorts. So the joggers and then the outdoor shorts. So this example, in this example, this particular product, the black sneakers, is more associated with the context of outdoor clothing or outdoor outfit. In the second example, if you notice, the black sneakers is sort of associated with more streetwear, where the customer is sort of browsing through more loose shirts and then your loose jeans in the last example. So the same model which we were working for the next item prediction or language modeling, we are doing the same thing for the product recommendation. And based on how you understand the context of this, right? The customer one should get recommendations which are more based on the outdoors or like the outdoor activities. So if you notice like those sneakers which have like high boots or which can be used for hiking or which can be used for outdoor gear, like those are more relevant recommendations for the first customer. But for the second customer, like these pairs of shoes also work fairly well because the customer is trying to get to like a streetwear or like more casual wear. So as long as we are able to understand that customer intent correctly, the recommendations sort of tend to get better. And that's the whole idea behind like why we are trying to model our products in a sequence of how the user is interacting. Okay, so now let's talk a little more about natural language processing and recommendations. So essentially, they're very overlapping fields in general. Like recommendations and natural language processing have been going hand in hand for quite some time now. So these are like very standard algorithms like word-to-vec, GRU, attention mechanism, transformers, BERT, ExcelNet, and then now GPT-2. So as the progress has happened for the language models over here, similarly, the recommendation systems have been parallelly developed for these language models. And there is this paper on transformers for rec. This diagram has been taken from there. So most of the development which was happening for the language modeling was very easily replicated for the recommendation problem as well. And right now, Hugging Face portal hosts like a lot of recommendation-based architectures which are sort of based on your transformer models, or they work on these NLP-based approaches. and they're fairly easy to try if anyone is interested in sort of spinning up a quick instance and just trying out some of these models. They're fairly like straightforward to try it through Hugging Face. Okay, now we can just get to what is Transformers for Rec. So Transformers for Rec is essentially a flexible and efficient library for sequential and session-based recommendations. And this was developed in PyTorch, and this was open sourced by NVIDIA around like I think 2020 or 2019 maybe. And the idea was that we, like as a user, we don't need to start developing this architecture from scratch. This will be sort of an out-of-the-box model where NVIDIA will take care of their architectures, the infrastructure, the models which will be hosted, and the users can, or like the data scientists like me, they can just use that particular model and develop a use case around it. So that was like the whole point of developing this library. I think one caveat over here is like if you want to use NVIDIA's library and you want to deploy it on a very large scale, you need to have access to some GPUs. On a small scale, yes, you can make it work on your laptop, but if you want to deploy it full scale, you will need like a good amount of GPUs for this. Okay, any questions so far before I go forward? No? Okay. Okay, so let's dive a little deep on the model architecture side. So essentially, this entire model has been based on 4 different components. So one is the feature aggregation, then one is sequence masking, then sequence processing, and then finally the prediction head. Now, and we'll sort of go one by one into these modules and what they do exactly. But just to sort of give a quick overview, like so the feature processing module over here is taking care of feature aggregation, data normalization. Then the sequence masking module is going to take care of your interactions, like how the customer has interacted with the products in a sequence. Then the once that interaction embedding is sort of created, we pass it through the transformer block. Then there is a fully connected layer which generates your prediction, and then there is the output layer. So let's sort of get dive deep on the component side. So one, let's talk about the feature aggregation. So before this data can be sort of fed into a particular transformer block, this data needs to be transformed in a certain way, which is acceptable by this library. And you can sort of break it down at a user ID and a session ID granularity. And you might have to define the sequence length, as in like how many products have been interacted in this particular sequence, and then what timestamps have they been interacted with, the product IDs, and then the category ID. So with the category ID, you can actually put a lot of different features. Like let's say if I'm modeling for a particular item, I can put the brand that item belongs to, the price that item belongs to, any promotional schemes which that item has gone through, the average rating that particular item has on our website, number of reviews that item has on our website. So it's fairly like customizable in terms of like what features do you want to keep and what features do you want to discard out of the model. And if you just want to do like some quick testing on which features are working out best, it's pretty good and handy to take care of that also. So this is how you will sort of do the feature aggregation, and based on this you will sort of create something called interaction embedding. Now interaction embedding is nothing but your vector representation of all the items which have been interacted with. So
sequence length
sequence length is essentially like how many products you have interacted with. So in the first row, if it is 6, there have been like 6 products which have been interacted with.
How is this different from product ID?
No, so the product ID is actual products which were interacted. The 6 is the number of products which were interacted. So that's these are essentially like this is the particular format in which you will have to create your data and then feed it to the transformer block. And one good part about this is they have a library called NV and NV helps you in getting your data into this format. So you won't have to like write a very big pre-processing module or something along those lines. You can just call this NVIDIA tabular library, and it takes care of the formatting and everything. Okay, the next step which comes after your interaction embedding would be the sequence masking. And sequence masking or like masking in general is a fairly common technique for training your transformers architecture. So the way it works is that you have a particular input sequence, right? A customer has interacted with product 10, product 4, product 33, 42, 50, so on and so forth. So what we are going to do is we are going to mask the last 3 products which the customer interacted with. We are not going to show it to the model that which were the last 3 products, and then we are just going to take the first like 7 or first 6 products which the customer interacted with, feed it to the transformer block, and then we are going to tell the transformer block to predict what items will be the next occurring items. So if the transformers predict it correctly, that hey, the customer interacted with 3, 12, and 23, then it's great, like it's working fairly well. But if that doesn't happen, then we'll sort of tweak our parameters again, and we'll change it in a way that we get at least as close as possible to the accurate product embeddings. The second approach is called masked LM, which is the masked language model. And in that case, what we do is we don't choose like the last 3. We randomly choose any 3 particular products, and we just don't show those randomly selected 3 products to the transformer. And then we ask the transformer like what are going to be those products missing from that random sequence. So if you notice, like in this particular sequence, we ended up hiding 42, then product 11, and then product 12. So if the transformer is able to correctly predict like hey which items were hidden, then yes, it's working well. Otherwise, we again train or we tweak the parameters. So you can select like any of these approaches, or you can try out a combination of these approaches and see like what is working out best in your case. There are like a couple of different approaches as well, which is permutation language modeling, PLM, and then random token detection, which are like very similar and more like statistical, and they work more on the statistical probability side. But it's fairly simple to try out these options as well if you're using this transformers for reg library. Okay, the next part is sequence processing. So sequence processing is like the main crux of like how you're going to process the sequence of items which were embedded. So essentially what you're going to do is you're going to pass this entire masked item embedding, and then the transformer block is going to predict like which items work or which items don't work. And essentially if the prediction is correct, you are going to go you're going to go ahead with those parameters. If the predictions don't work, then you're going to go and fine tune, or like you're going to change your hyperparameters and adjust your model accordingly. So sequence processing is like the main step where you are actually training your model or training the neural network for getting these blocks correctly. And again, the transformers for reg library has a fairly nice built-in this sequential block, and the sequential block will take care of like how it wants to go through this feed-forward neural network, adjust the weights, and then get the correct predictions. So yeah, fairly intuitive. Okay, the last thing is the prediction head. So the next module is the prediction head, where we actually determine like what is going to be the probability that which product is going to be shown after a particular sequence is given. So essentially we are assigning probabilities to these products or items, and the highest probability one is given the first rank, and then eventually the rest of the products follow. So a particular user interaction passes through transformers for reg library, and then you can choose like which transformer architecture which you want to use. and then you sort of get recommended next items. Now, this prediction head can work for multiple tasks. So the first task could be like the next item prediction, which we are using in recommendations. Like you give a particular sequence and then you get your recommended next items. The second application could be just binary classification to understand like you give a particular item a probability and then you set a threshold that hey, if this item has a probability higher than a certain threshold, this item will be relevant to a particular customer or this item will be recommended or not. So it works pretty good for binary classification as well. And then the third part would be regression. So if you are interested in understanding like how frequently is the customer visiting your website or how frequently is customer interacting with different items, you can model that as well. So let's say if you're interested in like how much time a customer is spending scrolling a particular item, and this happens a lot if you are working on the app side. Customers spend a lot of time on zooming in the items or like scrolling a particular item. So if you want to model that particular aspect, it works pretty good for like the regression-based approach as well. Okay. So just to sort of give a quick overview on the end-to-end production pipeline, I think there are a lot of parameters which you can sort of tune to get your model like perform the best way. So some of the parameters which I have listed are like the training columns, like which columns do you want to keep? Does the brand matter? Does the price matter? Is the particular item on a promotional campaign or not? Does it have any reviews? Does it have any ratings? So you can select like what columns do you want to choose for training your model. Then there is a dropout rate for training the neural networks, like how much neurons do you want to drop out at the training time. Then there is attention type. Do you want like single-headed attention or multi-head attention? Then how do you want to initialize your embeddings? Embeddings are essentially like you start out with a very random embedding, and then model in process of the training sort of gets you the right embeddings. So how do you want to start out with that embedding? What dimensions do you want to keep? Like, will it be 64 dimensional embedding? Will it be 128 dimensional embedding, 256, 512, so on and so forth? Then masking probability. So when we went over the masking slide, do you want to mask 3 items? Do you want to mask 4 items? So on and so forth. The masking type, the sequence length, like how far back do you want to go? Like, do you want to see the last 20 interactions of the user? Do you want to see the last 10 interactions of the user? So essentially, like it just depends on like what is working for your use case. If you want to model like a very long-term preference, you go far back, you look at their historical interactions and then see what is working out. If you are interested in very immediate session-based recommendation, you just see like the last 5 or 6 clicks or the last session's clicks. The other part is the interaction signals. What kind of interaction are you interested in? Are you interested in increasing the click-through rate? Are you interested in increasing the add-to-bag rate? Or are you interested in increasing the purchase rate? So depending on what kind of interaction signals you are interested in, you can choose only those particular sequences. Like just look at the customer's clicks, just look at the customer's add to bags, just look at the purchases, or just look at the items where they left a review. It just depends on your use case. Then the next will be attention heads. Again, for training your transformers model, you need to decide like what number of attention heads you're using. Then the training epochs, like the number of times do you want to train this model, and decide like what loss is acceptable to you, or like how much trade-off you're okay in deciding the training epochs and the loss factor. Then the number of layers, and then the date ranges as to like how far back do you want to go. So fairly customizable, and since it's quite customizable, it's sort of tedious also to get these parameters right. It requires a lot of hyperparameter tuning to get like the best model. And again, like it's a very iterative process. Okay, so just to sum it up, like so this is what the end-to-end production pipeline would look like. So your recommendations data set would be fed into the NV tabular library, which is again by NVIDIA. Then the pre-processed data set is sort of fed into your transformers block, where the model is getting trained and evaluated. And then this trained model is getting used for your online inference. So this online inference is again a server which is developed by NVIDIA, and they help you in understanding like how quickly you can predict your recommendations. So for example, on any e-commerce website, right, like if you want to update your recommendations real time, there will be always a factor of latency involved in it. Like so if I'm constantly interacting with it, and if I see the recommendations after 4 seconds or 5 seconds, that will be just too long. Like that time frame is not acceptable. So if you want to do like a real-time inference, these recommendations need to be rendered like within few seconds, like within milliseconds actually. And that is where the inference part comes in. Okay. Another aspect is evaluation. Evaluation is something which takes a lot of time on this, and it definitely takes time, but it's fairly like doable given that you have this framework and library already built in place. So for evaluation, we generally measure like the top N metrics. So precision and recall are like the standard metrics which are used for recommendation systems. NVCG and mean average precision are for ranking, like are the relevant recommendations showing up in the top rank. That's where you use NVCG and mean average precision. So these are like the metrics for offline evaluation. And then obviously you can run like A/B tests on it, where you divide the customer base into like 50-50, or you can do it like 33-33-33 if you're testing multiple iterations of the model. So these are like the evaluation aspects of this. I think the most important is the challenges which we face while developing these models. I think one challenge is definitely GPU costs. You need heavy compute to train these models, and if you have like fairly large number of SKUs or items or customer traffic, it becomes like even more difficult to train these. So GPU cost is definitely one. Then resources also for sure. So you will need like dedicated engineering team, data science team, then vector database infrastructure, inference and deployment endpoints. And you will also have to do a model monitoring and data maintenance, because as the new products sort of get into your system, or like the old products go out, or they're out of circulation, the trends are going to change and the customer interaction is going to change. So it won't be it won't be in a way that you train the model once and you're done with it. Either you will have to do like weekly trainings or daily trainings, depending on like how frequently your clothes or your products in particular get out of circulation or new products are added in. So another aspect to take care of. In terms of model, the challenges are the loss saturation. Loss saturation is something where your loss does not go down further no matter how much you train the model. So this can be actually taken care of by increasing the dropout rates or increasing your attention hits. Then the second aspect associated with this is getting the best hyperparameters. Since this model is like fairly customizable, it's tedious to get the hyperparameters right. Again, just to iterate, this is a very iterative process where you have to do this constantly to get the hyperparameters right. What interactions are you interested in? The add to bags, clicks, purchases, wish lists, scroll times. So fairly customizable. So you will have to sort of work your way through like what signal is working out best for you. So let's say on the checkout page, if you look at a particular website, you're more interested in the add to bags. If you are just interested in the home page or the discovery page, maybe your clicks are working out well. If you're just interested in increasing the customer engagement time, then maybe scroll times is something which you want to look out for. Then other than that, one more challenge which we would need, which will be over here, is how can we give new items more boosts so that they show up in our recommendation process. So one of the biggest drawback of this method is if the customer has not interacted with a particular product, that item is not going to be fed into the transformer block. If that item is not fed into the transformer block, we don't have context behind or like semantic understanding of that product. So essentially, if you want to push new products in front of the customer, you will have to develop like maybe a re-ranking layer or like a separate layer where you sort of give extra boost to the new products which have come into circulation. Maybe you can assign like a separate recommendation tray which just caters to your new products or newer products, because this model is going to struggle with getting that understanding if it does not have any history of interactions with the product. Okay, just to wrap it up, in terms of resources, feel free to use these. NVIDIA has like really good documentation for these libraries and frameworks. If you are interested in trying out Jupyter notebooks, feel free to look at this GitHub repository, which they have open sourced for examples. You won't be able to like make a production grade model, but if you just want to see like how recommendations work, how those interaction embeddings are working, these Jupyter notebooks are like really good to understand. They'll give you a small data set as well, and you can work through that. There are a couple of companies which have already adopted this framework. ASOS is one of them. So if you're interested, their tech blog is something which is really worth reading. I have taken like some of the references from those blogs. So yeah, and if you have any more questions, feel free to reach out, and more than happy to take any questions.